All right, so I'm going to go through sample problem number 24 using the information they give us in the book and using the method that we put into your notes packet. And in this method, again, you're given some percent abundances. Copper 63, this is the isotope of copper, is 69.2% of all copper atoms that exist on our planet, okay? And each one of those atoms weighs 62.93 AMUs. Now, copper 65 is the other isotope of copper. It represents 30.8% of all copper atoms, and its mass is 64.93 AMUs. So what we're going to do is we're going to use the process laid out for you on your notes packet. Again, assume 100 atoms. I know this is hard to read now. Multiply your percentages by your masses, add your answers, and divide by 100. Okay? So again, if we assume 100 atoms of copper exist, that's it, 100 atoms, then that would mean 69.2 atoms were copper 63, and 30.8 atoms would be copper 65. Okay, so what we're going to do is we're going to say we have 69.2 atoms, and each one of those weighs 62.93 AMUs. And I'm going to figure out, well, what do all of those atoms together weigh? Okay, so I multiply this in the calculator, and I'm going to get a pretty big number. But remember, we have to think about sig figs. Okay, so 69.2 times 62.93 in the calculator, it's going to give us a big number, but we're going to have to round that to just have 3 sig figs. 3 sig figs. Okay, we can't leave it as whatever it is in the calculator. We have to round it to 3 sig figs. This has 4, this has 3. Your answer has to have the same as the least in the problem. So we're going to get 4,350. Remember, we're rounding that to 3 sig figs. This 0 is a placeholder to keep it that same value, but limit us to 3 sig figs. This 0 doesn't count because no decimal point is written. All right, now we have 30.8 atoms of copper, and each one of those weighs 64.93. Okay, so we multiply those together, and again, 3 sig figs, 4 sig figs, so we need to only have 3 sig figs in our answer, and so we're going to end up with, oh, this one's not super nice for sig figs, but we're going to round it to 2,000. Now I know that this has only 1 sig fig, but this is going to work out later. We would have to put these in scientific notation to get the right number of sig figs. But we're going to round that to 2,000. Now what we do is we add our answers together. We get 6,350 AMUs. So all 100 atoms of copper together weigh 6,350 AMUs. Again, 3 sig figs in our answer. Okay. Now we're going to divide by the total number of atoms. Remember, this added together is a 100 atom sample. So this is 100 atoms all together, and all 100 atoms weigh 6,350. So 6,350 AMUs divide by 100, and we'll get the weighted average mass of copper is 63.5. This has 3 sig figs. 100 is our counting value. We had 100 atoms. Okay, so if you were counting out atoms, that's an exact value, wouldn't have infinite sig figs. So 63.5 is 3 sig figs, that matches our lowest value. AMUs is the weighted average mass for copper. So this is why when you look in the periodic table, we have 63.5 AMUs. It's not a whole number because some copper weighs 63, some copper weighs 65. So the weighted average mass is going to be closer to 63 since that one is more common in nature. Okay, so if you do this same process in number 25, you're going to end up with 79.90 AMUs, 79.90. That one ends up with 4 significant figures because the masses and the percent abundances all have 4 sig figs. So we end up with 4 sig figs in our answer. Okay, all right. Remember, sample problems, the answers are in the back. The work to get to the answer is also in the back, but their work is not going to match this method. It's okay if you use their method instead of ours, but most of our students in the past have shown that this method makes more sense to them mathematically. On the next page, you're going to see answers to our lesson check and our standardized test prep. Thanks for tuning in, and we'll see you in class.